So today we are continuing in Chapter 2, and I want to, now that we know how to do polynomial division, we're going to step back into polynomials. So our goal here is we've looked at polynomials of higher degree, and our goal here is to be able to graph them and to find the zeros of polynomials. Now up until this point, we've only been able to do very specific ones. Either they were quadratic and we can solve them using the quadratic formula or factoring, or another method that we're partial to, or if they were a fourth degree polynomial, then they had to factor a certain way, kind of like a normal quadratic, or maybe there was a common factor we could factor out of it. But we want to go a little further than that. We want to be able to factor any polynomial and find its zeros. And so we're going to start out, I just want to talk about this remainder theorem here I have written down here. So first we're going to divide f by this x minus 3. So first I'm going to write it as a fraction, which implies I'm going to take x minus 3 and divide it into x squared minus 2x minus 1. Okay, so I'm not going to spend a lot of time on this. If you need to refresh, then go back and watch that lecture again. So I have x times x will give me x squared, and then I multiply it by the x by the minus 3 and get minus 3x. I'm going to change my signs and add. This gives me x minus 1 when I bring it down. X times 1 gives me x, so I need a plus 1. I write the x minus 3 here, I distribute, and I change my signs and add. I get a remainder of positive 2, right? So I could write this as plus 2 over x minus 3. Now I want to show you what happens when I plug in. So this is the factor, right? So kind of using that idea of the zeros, that means that the solution to that was x equals 3. So what I want to do is I want to take this 3 and put it in my f. So what is f of 3? F of 3 is 9 minus 6 minus 1, which is 2. So do you see how when I put that value into my f, I got out 2, which is the same thing as what I got when I divided x minus 3. I got the remainder of 2. So that's part of the remainder theorem. I didn't prove it, but I've just kind of shown an example that it does work. That when a polynomial f of x is divided by this factor, x minus k, then the remainder is f of k. So that's equal to r, which is the remainder. So we want to use this idea because the thing is if I'm finding solutions to f of x equals 0, now I kind of have an idea that when I want perfect factors, right, something that I'm going to get this is kind of the same thing, right? I want my remainder to be 0. So when things are perfect divisors, meaning they divide evenly, like 2 divides into 4 evenly, when a polynomial factor divides into another polynomial evenly, then I'm going to get a remainder of 0. Alright, so what we want to do with this polynomial, f of x equals 6x cubed minus 19x squared plus 16x minus 4, is find all the solutions for f of x equals 0. Okay, eventually we'll find these and then graph it, but for right now we'll just find the zeros of it. Okay, so we want to use the idea that f of a equals, or that basically if I get 0 as a remainder, right, I had the remainder theorem that said that if f of r is equal to 0, right, then that means that the remainder is 0. So I want to use that idea. And so I'm going to take this idea that 2, 0 is a point on my graph. This is a given right now. So eventually we'll be able to find these on our own. But for right now, we don't really know how to find these. So I'm just going to be told that the point 2, 0 is a point on my graph. So this implies that 2 is a 0 of f, right? So I could write it like this, f of 2 is 0. Also, because 2 is a 0, I could say that x minus 2 is a factor, right? So that means I'm going to take my polynomial and divide it by this factor. Now, if this is a 0 and it should divide evenly in, then that means when I divide this, I should get no remainder. So that should be a hint that I'm doing something right. Okay, so let's go ahead and divide. So I have x, I'm going to multiply it by something here that's going to give me 6x cubed. So that would be 6x squared. So I'm going to write that above my squared term. I multiply back through. This will be 6x cubed minus 12x squared. I'm subtracting, so I'm going to change my signs and add. Okay, so these two cancel out. I'm going to get negative 7x squared. I'll bring down the next 16x here. Now I need to multiply I need to multiply x by something that'll give me negative 7x squared, so I'm going to need a minus 7 and another x. I multiply through and I get negative 7x squared plus 14x. Again, I'm going to change my signs and add, so I get plus and minus. So this is going to leave me with 2x minus 4 when I bring down this 4. And now if I multiply the x times 2, it'll give me 2x, so I get plus 2 up here, and I end up with 2x minus 4. When I subtract, change my signs and add, I get 0. Okay, so that means that f now is, I have it slightly factored. So I could write f of x now as, so this is the one factor, this is the other. So now I'm going to write it, instead of writing it like this, I'm going to write it as multiplication as x minus 2 times 6x squared minus 7x plus 2. Now I'm not completely finished here because I wanted to find all of the zeros. But the goal is, basically the rule of thumb is, once I get it down to a quadratic, I can always factor it. Okay, so that means either I can factor it or I can use the quadratic formula, so maybe I can't necessarily factor it, but I can always solve it if it has solutions. So the goal is basically to divide until I get a quadratic factor that I know how to deal with without division anymore. So let's factor this one a little bit further here. Okay, and so this will actually factor, let's just do the box method here. Okay, so if I'm going to do the box method here, then I know I'm going to have the 6x squared here and the constant term here. So I multiply the 6 times the 2 and I get 12. This means when I add the two factors together, I should get 7. So let's see, what is that? 3 and 4 give me 7, and they both have to be minus, so my two x terms are minus 3x and minus 4x. Okay, so I know I'm going to have an x here and an x here. Okay, so I think I'm going to need a 2 here because these are both multiples of 2, and a 3 here because these are both multiples of 3. So now if I multiply this times something over here, I should get minus 1. And this should give me minus 2 here. So does that work then? Negative 2 times negative 1? Yes. So my two factors, I have f of x is equal to x minus 2. Now I can write it completely factored as 3x minus 2 and 2x minus 1. So if I wanted all my solutions, right, to f of x equals 0, well, I already knew that f of 2 is equal to 0. And then I can set these both equal to 0. This is going to give me x as 2/3, and 2x minus 1 equals 0 is going to give me x as a half. So I know that f of 2/3 is 0, and f of 1/2 is 0. So this is a new way that we can use polynomial division to help us with our factoring. Okay, so just a couple of other little things that I want to talk about really quickly here. Okay, so first of all, if I have division, right, how do I know when I can divide? So if I have r of x is equal to f of x over g of x, right, then if f has a degree that's larger than g, then this is considered an improper fraction or improper rational function. And that means that if the degree of f is higher than the degree of g, then that means we can divide g into f, right? If g has a bigger degree, right, it would be kind of like, the difference is, you know, if I had a fraction, then basically if I had 7 over 6, then I could divide the 6 into the 7 and get 1 and 1/6, right? So I could do that. But if I had 5/6, for instance, if the degree is smaller, then I mean, I could do the division, but it's going to be less than 1, so I'm not going to do the division. So basically, we only divide things when, and it's considered improper when f is the same degree or higher than g. So if I had like x plus 1 over x minus 2 is f, then I could also divide this. Okay, so this would be improper because the degree in the top is 1 and the degree in the bottom is 1. So that's just some terminology. We use that, that's used quite a lot actually in Calc 2. All right, one other thing is, as we've already talked about this, but I want to reinforce it. If x minus a is a factor of f, then when I divide my function by x minus a, then I should get no remainder. Sorry about the growling. Okay, so we saw that in the previous example. So if x minus a is a factor of f, then when we divide, maybe I should call this f instead of r. We divide f by x minus a, then we should get no remainder. So that's a way that we can catch any of our mistakes, because polynomial division can be a little complicated. All right, until next time.